Thank you, everybody. It is my absolute honor to be here. I'm really glad that the last couple days I've got to spend with a bunch of you and got to meet a fair number of you. The tutorials were absolutely amazing and really, really high quality. The talks yesterday and the lightning talks were great. Lynn's keynote. This is just a fantastic conference, and I'm really honored and grateful to be here. At the end of my keynote, I am going to, I have quite a love for Bucky, and I was told we could put stickers on him to commemorate this wonderful event, and hopefully more will be added over time. So today my talk is called Thriving with Python in a Polyglot World. And it's not a beginner talk, it's not an advanced talk, it's not a technical talk, it's not a non-technical talk. It really has a mix of everything. So hopefully wherever you are in your Python journey, even if you haven't started yet, hopefully some of this will resonate with you. And Heather's talk yesterday really touched my heart, and I think you'll see maybe little snippets of what she was communicating in that talk. But do watch her talk if you didn't see it yesterday. So most mornings, I do not spend on stage like this. I spend walking on the beach, and it's my chance to think about tech, people, what's going on in the world, and sometimes just the cool stuff that I see. And one thing that I've been thinking about a lot is, where does Python fit in this world of languages? And should I be switching over to Rust? Should I only use Julia? Should I be using R? JavaScript, TypeScript? There's a lot of languages out there, and although I love Python for many, many reasons, I actually like a lot of other languages because I just want to get stuff done. And depending on what I want to get done, JavaScript might be a better choice. C++, maybe, but maybe not. And not a knock against C++. I did it for many years, and I still do it. So I'm Carol Willing. I tend to like the beach and all things related to water. Mason did a good job explaining who I am and what I've done. But really what I am is a beginner every day. And by that I mean, I don't know what it takes to succeed tomorrow. I have some ideas, but I'm constantly learning new things. There are things that are really hard. It took me a long time to wrap my head around JavaScript and TypeScript and the tooling around it, and I really relied on a lot of other people to help me get there. So my hope today is that I will be able to help you share my knowledge and use it for what it's worth. It might be worth 1 cent, it might be worth more, I don't know. But to sort of highlight some of the pitfalls that you might run into over your careers or adventures with tech. And I'm 58 years old. I've seen a lot of stuff, and I'm hoping that I can share some basic tips on what I think has helped me persist. And I think they're universal things that other people could apply as well. And then what I'm going to do is take 3 particular pitfalls and talk about some of the things about how Python relates to it and other languages relate to it. And if I use jargon that people don't understand, just raise your hand, because I try really hard not to get too in the weeds. But I also recognize that people are advanced programmers as well, and they would like to learn about what's coming out in Python and what's on the horizon. So with that, how do we choose which languages to use? There are a lot of different types of languages, and many problems could be solved with any language. some of the ones that are more performant are the ones like Rust and Go and C and C++. Python is actually pretty performant now as well. And, other things like JavaScript and TypeScript, they're your gateway into working in the browser, working in mobile, and the other languages all serve their purposes as well. So my takeaway from this is choose whatever works for the thing that you need to do. And hopefully Python will be part of that. So the 3 pitfalls that I'm going to talk about today are chasing speed, which is a very common one that we hear all the time in the media. Swooning over the shiny. There's this nice shiny thing. Oh my gosh, I should be using that now. And then the third pitfall, which I think is often the hardest, is hype and the fear of missing out. And you only have so many hours in the day. And oh my goodness, OpenAI, ChatGPT, what's going to happen? I should switch to it now. I should learn everything. Well, we'll see about that. So I decided to bring some friends along on this journey because people like Lynn, who I've known since, I think, 2014, they've played such a huge part in my confidence with Python, in my enjoyment of working with Python. And even if you don't have a Python friend right now, we have lots of ducks. And for those of you that have done Django Girls or something like that, ducks are when you try and explain a problem that you're having with coding to a duck. And the thinking is, as you talk through it, maybe the duck will respond to you, I don't know. But you usually find the answer as you kind of talk through the problem. So I have a bunch of ducks. And as we look forward to next year or tomorrow, what should you do? What should I do with Python and other languages? So I decided to ask some of the experts. And these 4 gentlemen have each created some more than one languages. On the far left is Guido van Rossum, which he started Python. And for those of you that are curious whether he knows everything about Python, the answer is no. Python has gotten so big that no one person can understand everything about Python. James Gosling, Anders Heilsberg, Larry Wall, and myself. And I've done this panel twice, which I was super nervous about. And one of the girls that I had known since she was like 8 years old lived up in Seattle. And I was like, I'm really nervous. I've got huge imposter syndrome. And she's like, why? She works in tech now and is very accomplished in her own right. And I'm like, because they've created languages. And she's like, yeah, but none of them worked on Jupyter and got an ACM award for the impact that Jupyter had. And I'm like, oh, talk about being schooled by the person you watched grow up from a little child. And it helped. Having her in the audience helped as well. So let's bring these folks along with us, because one of the things I learned from talking with them is one of the things they value most about the languages they've created are the community and the people who have contributed and used the libraries or the languages. And I was a little surprised that that was universally the most important thing to them. Change is going to happen. That's the other thing. And you can't predict the future. So we're going to take them on our little journey. And for a minute, I'm going to take you back to my start in programming. And I've had a very untraditional path. I actually took a 15-year break from tech to raise my kids, because that's what rocked my world. So I make it a point to share that because there's a lot of myth around, oh my gosh, you've left tech for any reason for a month, a year, 3 years, and you can't come back. And that is patently false. It may take work, it may take help from folks at a user group, but you absolutely can. And it won't look the same as when you left. But I'll tell you, the only thing that really changed when I came back was learning new languages. That wasn't hard. Learning Git, because when I left, it was like RCS, CVS, and SVN, and Git, I could not wrap my head around the mental model, push, pull, rebase. It was confusing. And it took a lot of folks sitting with me, advanced programmers, saying, oh, you don't want to do that, or don't follow, all the things that you Google on Stack Overflow. Find one workflow, stick with it until you really feel confident, and then start experimenting. And that's what I did, and it was super helpful. So we're going to go back to a time before many of you were even born, which is kind of cool. And this is actually me at the age of 11 when I was in middle school and at 7th grade. And that was not when I started programming. I actually started programming in 5th grade. I grew up in the shadow of Bell Labs, and much like we do today, there was an outreach program to help kids learn how to program. Now, programming was different then because when I was at Bell Labs, it was on a big mainframe. It didn't have a screen. It kind of had like this typewriter thing. But one of the things that I thought was really cool is they were working on this music machine that would do all kinds of cool stuff. And that really fascinated me because I'm really into music. So anytime I try and learn a new language, a new library, I try and see, okay, can I apply music to it somehow? And when I was in 7th grade, the Apple II, our school had one of the first ones, and I was one of the first people that got to use it because as an 11-year-old, I went to public school, but the public school I went to had a pull-out program for people that were good in math. And so, there were 4 of us in the class, 3 boys and myself, and they said, I walked into the class because I did not want to be there. I wanted to be with my friends, my soccer team, doing other fun stuff because this was a half a day kind of thing. And I walk in and they're like, we're playing Dungeons and Dragons. Do you want to play? And nothing against Dungeons and Dragons, because I actually think it is kind of cool. But at that point in my life, I was like, no. And so the teacher was like, well, you need to find something to do for this quarter. And so in the corner was the boxed up apple. And I said, can I do that? She's like, yeah. And the other thing was, doing this college psychology class. So I'm not sure how the two relate, but it was an experience. And I say that because back then, we didn't have tutorials. You had to just explore and experiment. And so what do you do when you get a computer for the first time? You try and make a game. And so I ported Atari's Breakout game to the Apple II, and it took me probably 6 months, but it was so cool to kind of explore. And that was something that has always resonated with me, that sense of exploration, experimentation. So in the 80s, college, grad school, I was doing not computer science. I did electrical engineering, and then I did applied economics, but I was always programming, and those were the languages that I started using in the 80s. Mobile phones were just coming on board at the end of the 80s. There were no smartphones, there was no web, there was no Google, there was no Linux, there was no Python. However, there was artificial intelligence. So when we go back to the hype, artificial intelligence has been around for a long time. And Byte magazine was a very popular magazine because we didn't have the internet. We'd thumb through these, we'd wait until it came out each month, and then we'd try whatever we saw in there. And Geoffrey Hinton, had an article in there, and many of the same artificial intelligence questions that are being asked now were asked back then. We didn't have the compute power that we have now, but it's not as new as people would make you believe. So through the decades, life took me in many different directions, and these are all languages that I've used to some degree. It's not when the languages came out, but when I first started using them. So I came to Python in probably 2012 by accident, and really loved it and loved the community even more. And what I loved about Python was it was visually clean. And for somebody who has a little bit of an ADD brain and things get overwhelming if there's too much stuff on the page, Python was a totally different look than other languages that I had used in the past. It started reminding me of using that Apple II computer. And so I decided, okay, let's see where this journey goes. And what I saw over this time was lots of paradigm shifts. And I think we're at a paradigm shift now. There is definitely going to be an impact of LLMs and the current state of machine learning on us. I don't know what it's going to be, but I do know from all these other paradigm shifts that I saw that there was always uncertainty, and it was a lot of trial and error at start, and then learning from that and continuing to learn. So how does this relate to us? And we're going to bring our little PyTexas duck along with us on this journey. And I think it starts with following your North Stars. And by that, I mean, start first by embracing a musician's mindset for mistakes. When you're learning an instrument, you are not an expert player at the start. You make lots of mistakes. You make lots of mistakes even when you've been playing for a while. And one of the things, my son plays trombone, and his instructors always said, just play loud and proud. So even if you make those mistakes, just keep going. And there's something to be said for that. And I kind of have, that's resonated with me throughout my career. Another thing is, when kind of stuck or in doubt or kind of perplexed as to what to do next, I found that taking a baby step in any direction is a good thing to do. And Lynn talked about design yesterday. There is a technique within design and creative problem solving called Scamper. And I say this, I should point it out because I think it helps with debugging. It's, look at the problem from different perspectives. Can you substitute things? Can you combine things? Maybe I need to take something out. Maybe I need to reverse the order of things. And it's just a helpful tool. But probably the most important North Star for me has been understanding my why. And for me, what has always been my North Star is making learning accessible to everyone. And if I look through the sum total of my careers, including the Jupyter notebooks, it wasn't from the standpoint of, I want to make really cool code that everybody loves. It was, okay, how can I get these concepts to people who maybe aren't computer developers so that they can use it? And it's really that sharing of knowledge. So understanding your why is important, because when you get stuck, you need to know why you're persisting. So let's all today tackle some pitfalls, and we'll kind of go through them fairly quickly. So hopefully we'll have a little time for questions. And that first pitfall was chasing speed. We hear sometimes Python's a slow language. Well, what does that even mean? Because there's questions to ponder when you talk about speed. What are you measuring? How do you measure it? What's fast enough? And then those four things, performance, reliability, flexibility, security, all have to fit in that equation of speed. And so it's all about making trade-offs. Which language you choose, you're making a trade-off each time you choose a language or a library even. So how do we make Python feel speedier? I guess if that's what you want to say. Use a recent Python. It's much more performant now than it was 5 years ago. And then if that's not fast enough, try Py. And then there's other things you can do as well. You can profile your code, and so measure how it's performing, figure out where the slow spots are, and then optimize. So one of the things that I kind of like, and I'm going to point it out here, is PySpy. And one of the things I like about it is you can use it on a running process. And just by having that one line PySpy record --PID, and then the process ID of the process, it will generate a flame graph, which then will let you see where the slow spots are. And there are many different profiling tools, but I encourage you to check them out and measure first before you optimize. And then I've included, I'm going to put the slide deck up, a few real-world examples of people who've walked through profiling their code and optimizing it in different ways. And this was just one example that goes into very, very huge depth. But another person's work that I really respect is Itamar's. He has a website called pythonspeed.com. Those of you that are in the data science arena should definitely check it out, because he's got a lot of well-vetted, well-researched approaches for how to speed things up. And that's the benefit of having somebody else's knowledge. There's only so many things I can look at in a day, but I can definitely use other people's stuff to get even better performance. GPUs and JITs are another way. Throw hardware at it, throw a different technology at it. A lot of you who are computer gamers might have NVIDIA GPU cards in your systems. It's actually used quite often for machine learning, deep learning, and there's a library called Numba, which will speed up things just by adding a decorator. And you don't have to add a decorator to all your functions. You can just add it to the slow one. So something to keep in mind. Moshe gave a talk yesterday, and I've respected his work for a long time. And when do you bring into Rust into your Python code? And I think that just sums it up. Prototype in Python, and if you have a performance bottleneck, then look at Rust. And Rust can very straightforwardly wrap your code so that you can have, you're still using Python, but you're wrapping that Rust code so Python can use it. And the docs are great, and there are some really good examples out there. Other things, we've got a lot of Bloomberg folks here. Pablo is a good friend of mine, and they've put an open source, thank you Bloomberg for open sourcing, two really cool tools. One's a memory profile, and others like a stack trace debugger, and they're sort of game changers in the fact that they don't add complexity, if you will. They just give you more knowledge and let you make better decisions. So check that out. I really like Rough. There's a question of, Rough lets you like lint and apply formatting and run a bunch of the tools that were individual Python tools quicker. And do you need to run it quicker? We were having this discussion yesterday. It depends. I mean, it's nice in CI if you have things that run really slowly to maybe accelerate it, and if you're paying the bill to GitHub and others for the runners, it might be nice to cut some time off. Playwright, huge fan, cuts development time. And then the other thing is prototyping speed. Something with Python that I think often gets overlooked is how quickly you can prototype relative to other languages. And a big part of it is because of the many, many libraries that we have out there and the structure of the language itself. And Jupyter Notebooks, I think, has been a game changer for providing examples to people, letting people run code on the fly. I don't typically put notebooks in production, but some people do. So it's totally cool to use it and prototype it and then move to something else. So the next pitfall is swooning over the shiny. And, this is where media, the Bird site, and others really hype up what's out there, what you should be using. And in my experience, the grass is always greener in another language until maybe you start using it. And I'll use packaging for an example, not because I think packaging is bad, actually. Huge props to the folks that are working on it. But some people will say, oh, Rust is so much faster, blah, 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 blah. Well, it's a newer language. They will have more fragmentation over time when it comes to packaging. Somebody told me JavaScript, it's so easy, you just install it. I can tell you from working with JavaScript in production, it is not easy. There's like 5 different ways to install many different things, and there's as much confusion there as which tool to choose in Python. And packaging is a hard, complicated problem. So maybe it's worth jumping to another language, maybe not. We've actually hit the point where if you're writing a pure Python package, it works pretty well. And huge thanks to all the people who have been working this past decade on packaging and installation and all the things. It is really come a long way in the last decade. It's not perfect. We've still got work to do. I think Bernard's talk yesterday was probably the best talk I've ever seen about maintainers and the pragmatic side of maintaining projects. So, keep that in mind as you create your own projects, and then reach out and thank a maintainer of a project that you're using and you get lots of value. We get lots of complaints. The number of complaints to the number of thank yous, like genuine thank yous, like, hey, this helped me save, blah, 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 blah. Not just thanks for the pull request or whatever. Those we get a lot of. But we don't get a lot of the how it has impacted your project. So take a moment and share that. PyOpenSci is a nonprofit that I'm working with that is helping to share education with scientists about how to package a project. And it's something that I think is needed because, packaging, when you're a maintainer, you're focused on fixing bugs and all the things that we went through yesterday. Documentation is a hard thing to do. writing good documentation that is understandable, accessible, is not trivial. And I love writing documentation. The number of times that I have been told, yeah, that's not technical. Okay, well, can you please define to me what you're using as the benchmark for technical? Because I can code. I love coding. I also love writing. I love teaching. And, you know, all of these aspects of development matter. So, you know, think about what's important to get people to use your project. And I think documentation's a big part of it. And I used to tell my students at Cal Poly, if you can't install it, it's a useless project. So definitely READMEs, installation. There's some new tools that are coming up. I'm not gonna go too much into them. Pixie's one of them. It's somebody who's been in the scientific Python ecosystem for a while. We'll see. It's worth playing around if you're in that area. I stumbled across a development tool that Rough is using that's sort of a playground for generating abstract syntax trees, which, jargon alert, is basically how you parse and display the different words in a language. And I've got a better example here, like an expression or an import statement, all gets broken down into smaller and smaller chunks. And so for those technical folks who are more advanced in your journey and have worked with wondering how is this all working behind the scenes, this is kind of cool because it gives you a way to display it easily. There is a Python library that you could do the same thing. This is a little more visual. Pyo3 is the library that is pretty much most widely used for packaging up Rust code to run within Python. And Pydantic is a very popular library now, along with Fast API. Pydantic is using Pyo3, and they've got really good best practices on how to use it. So I point that out for those of you that want to use that. This is something I added to my website. I was working with somebody locally who had two daughters that were 6 and 8, and she had been telling them about PyLadies and the impact that PyLadies has had. And I said, you know, it'd be really cool to make an example that they could just run without having to install anything, without having to, all in the browser on their phone. And so I added this to my website using Jupyter Lite, which also uses Pyadide and WebAssembly. And we'll see if the demo folks, this made my laptop die, but basically, you're basically running Jupyter Lab in the browser without having to install anything. Uh-oh, I might have just stopped it. Maybe it's still going. This just about killed my laptop by just putting the GIF in. It works fine on the real website. But basically, you're going through and you're implementing the steps, and not just in Python. One of the examples I had was actually, I'm going to give up on this slide completely, but processing P5.js is a great way, because it's very visual, to get folks that are new to computing to build confidence, and it comes with a lot of examples. So, you know, putting that on a website probably took a half an hour. The documentation's really good. And I think most of the folks that are in here probably could do it. And those of you that are newer probably could do it with pairing with somebody else. So if you have any interest in that. Our automation panda did a great playwright talk, and I love playwright for many different reasons. One thing I will point out is that there's actually a playwright debugger that is really good and interesting because it lets you step through the tests and see what's going on. So just like a regular code debugger, it will go and it'll highlight where it is and show you on the page where it is. It will also have like a log of everything that it had done, which is kind of cool when you're debugging. And it's just fast, and the barrier to entry is relatively low. So my last pitfall is hype and the fear of missing out. And import anti-gravity. We can all fly. We can skip all the TSA lines. It's all good. Life is fine. We can all go home. I wish it were that simple, but it's not. And Sandy Metz, who's written some great books in the Ruby ecosystem, told me once over breakfast, I'm like, how do you keep up with all this stuff? She's like, I just pretend it's news. And I was like, what does that mean? And she's like, well, you know, regular news. Some of it you listen to, some of it you don't. You use it when you want to use it. And that was really helpful for me because it took the pressure off of, oh my gosh, I have to stay up to date. I have to stay up to date. I have to stay up to date. Remember a year ago, the hype about how ChatGPT and OpenAI was taking the world by storm and it will take all of our jobs and this and that. These articles came out in the last few days. So we've now gone to the other side of, oh, AI's a hype, blah, 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 blah. This is actually pretty typical for when you see a paradigm shift. You will kind of oscillate around where you ultimately wind up a year or so, 2 years down the road. Lots of new libraries, some are open source, some are not open source. You know, many of the other talks today and yesterday will do a better job and go in more depth. I do want to highlight the work of a friend of mine. Dr. Brandeis Marshall wrote a book last year, it came out last year, and it really talks about how do you bring these data science skills, like life skills, to the larger population of people who will be impacted by the tools that we write, the algorithms that we deploy. And I think it's really important because maybe I'm just the annoying person in the room as a kid that always asked why. Why? Why are we doing that way? Why? What is the impact of that? And I think, you know, making things accessible to more people demystifies it. It adds more transparency, and I think it just brings the level of using these tools up. When I did my PyCon talk, I talked about different trends that we're seeing in the industry and critical global issues. I am concerned about all of them. I program to change the world through learning. And whatever your view is of all of these things, you're somewhere in that. And your work will impact that. So the last thing I'm going to really say about hype and the fear of missing out, what if I don't try it today? Well, if I try it today, I might get a basic understanding or understand from the ground floor and have less of a learning curve later. 6 months from now, there'll be more examples out there. You've got more peers and their experiences you can draw off of. 1 year later, better tooling, better docs. 5 years from now, I mean, Python's a 30-year-old language. It's still going to be here, unless the maintainers go away because you don't feed them nicely. I I have a passion for cognitive science, which is basically a fancy word for combining all the things that relate to how people learn and absorb knowledge. And I think this, as developers, we innately do this every day as we learn our craft and move forward. So we've gone on a journey. We've walked through some pitfalls. And I think my hope is you feel better equipped to be successful, whatever your journey is. Just to recap, making mistakes, expect to make them. Take a step. Whenever you feel blocked, take a baby step. It's cool. And then, if the technique for Scamper works for you, great. Always try and understand your why. When you get really blocked or burned out or whatever, knowing why you're doing something is really important. I spent the last 3.5 years working at a startup, building a SaaS project based on Jupyter stuff. It didn't fulfill me, and I wound up being really burnt out by the end. And now I know why. Because I put a lot of my teaching work and curriculum writing and things like that on hold. So now I'm going back to my why. Treasure your time and your energy. These are the two biggest resources that you have. Treat them as precious as they are. Say no. No is a one-word sentence. You don't need to tell people why you don't want to do something. Just say no. And the energy, get away from your screen from time to time. It does help. And then I think the most important thing to me is fun builds resilience. I have been doing computer programming for almost 50 years, and I take joy in it. I look for the cool stuff. And, a lot of times it's with music. So what's next for all of you on your Python journey with other languages? There's a lot of them there. Given that you're here, I'm sure Python is centric to most of them. We are in Austin, so I suggest creating a band. And I'm going to name it Python and the Polyglots. And we're going to introduce our first hit song, Thriving with PyTexas. This has been an amazing conference. Thank you for listening to me. I hope you learned something. I will put this on my speaker deck later today, but just go be awesome. And if you're looking for a new podcast, there's some PyLadies that have a really cool new podcast out that really is highlighting some of the folks that do a lot of work in Python that you might not normally see. And with that, have a great rest of the conference, and thank you. How much?
For the record, my vote for band name is the pull requests.
The pull requests.
Push and pull.
I tried to take a picture of Bucky and wanted to put him in the band, but didn't have a photo from yesterday. So.
Oh, we could have facilitated that. Is everybody able to hear me? Yeah, sweet. We have a bunch of questions in here, so I'm going to hit you with those rapid fire.
Yep.
What are the signs that you look for when determining if a shiny technology has become tried and tested?
If it's become tried and tested, the amount of things I just run, I go to the installation instructions, I install it, I play around with the basic example. If I feel like, okay, this might help with my work, then I continue on. If not, I might say, okay, not for me, not right now. And then if there's something that sparks my interest a year later, I'll do the same thing.
Nice, okay. When someone comes to you for help with Python, what are some of your go-to ways to help them?
I have a rule of thumb that I shared with students at Cal Poly, which was if you've been struggling with something for half an hour and not making any progress, typically the reason is there's either poor documentation, unclear examples, or you're missing some cognitive piece that if somebody shared with you would unlock it. And so I would try and sit down with them and say, okay, tell me about what you're trying to do, what you're trying to solve, what have you tried? I'm sorry. I'm a little... All right, I'm technology.
Silence timer.
That was so. You're supposed to be done with your Keynote timer. Well, now totally derailed me. But I think talking it through, like rubber duck, whatever, is how I try and help. If I read a lot of code, I review a lot of code, I think there's something to be said for looking at really good examples of the thing you're trying to do. And so I would try and point them to somebody who had done it, something on GitHub or whatever, and then say, well, see what you learn from that, and just feel free to come back to me.
Nice, okay. Next one I've got here is 1 to 2 years ago, the big tech hype object was blockchain technology. What gives you confidence that AI will actually stick around in the long term?
It will. It's been here since since the 1950s, if I really want to be pedantic about it. But, the hype will be there. But, I can see applications like in science where machine learning is really improving how we detect anomalies in a visualization. So for scans that are done for cancer or something like that, having another set of eyes that have far more detail and, it's helpful. So blockchain is still going to be around as well. Maybe not in the hyped way that it was. So, you look at these technologies and they often build upon each other. So you take what you find useful, discard the rest as news.
Nice. I'll do 2 more.
Okay.
Is there a place for boring software that doesn't advance as much but just works?
Absolutely. I love boring software. Well-written software that just works. There's no need to be fancy. Understandable is key. If you've ever had to refactor a spaghetti rat's nest of code, that's why you write tests. If you ever think you're going to refactor something, and believe me, you will, because most of the work we do is maintaining code, not writing code. Like 90% is maintaining code. So boring, well-written code, A+. A+.
All right, last one I'm going to hit you with.
Yep.
What are your tips to handle imposter syndrome?
I have a few. First one, take that baby step. I think that has helped me. Being open about it has helped me as well. That could backfire, I could think. But, there are a lot of really high-profile core developers that have imposter syndrome. I think one of the things about imposter syndrome is you're pretty self-aware. And you have this knowledge of what you know and what you don't know. And if I look at the sum total of computer science and tech, what I know is a small droplet of everything that's out there. And I'm aware of that. And that sometimes gives you that, oh my gosh, I'm not qualified to talk about it. But your thoughts do matter. And I think getting outside, finding people who aren't in tech they are wonderful for giving you perspective back. They're like, because they give you a perspective of not tech. And then, PyLadies is a great example of, there have probably been times that I've gone to Lynn and I'm like, I don't know how to do this. And she's like, yeah, you do. Let's work through it or whatever. And so imposter syndrome is just a phase in a journey. And by taking that next step, you're already on the next part of the journey.
I'll add my own thoughts on that too, to say that I think that when you're experiencing imposter syndrome, it's because you're comparing yourself to someone else.
Yes.
Ask your why question. Why are you comparing yourself to someone else?
Yes,
Because
that
the
is.
answer is probably there's not a good answer.
That is spot on. So with that, I will be around the rest of the day. It has been my honor and privilege to chat with you. Thank you for listening. Go take a break, I think.